Okay. So, tuloy natin, no? So, yung last time. Okay, so yung kahapon. Okay. So, dito tayo natapos kahapon, no? Okay, so again, so dun sa solid of revolution. Tama. Okay. Solid of revolution, no? So, punta tayo dun sa next problem natin.
Recording in progress.
Okay. So, problem number 8 na tayo, no? So, dun sa handouts natin sa integral calculus, no? Okay? So, this time, so we have an ellipse, no? So, we have this equation, okay? So, which is revolved about the line x is equal to 3. What is the volume generated? Diba? So, ito naman yung tanong sa atin this time. Diba? So, again, x is equal to 3 is a vertical line, diba? So kasi x. So tapos passing through x is equal to 3, diba? And for our ellipse, diba? So ililipat lang natin to sa standard form. So we have 4x squared plus 9y squared is equal to 36, no? So since wala tayong x term, wala tayong y term, diba? Kasi pag meron tayong x term saka y term, so ibig sabihin we are not centered at the origin. Pero pag wala kayo nakikitang x term saka y term, wala ding xy term, we only have the x squared, the y squared, and a constant. Diba? So alam natin that this is either a circle, an ellipse, or a hyperbola, so which is centered at the origin. Diba? So pero sinabi naman dito ellipse. Diba? Kaya alam natin na ellipse to. So para mailipat natin sa standard form, we just need to make sure that the right-hand side, the constant term is 1. No? So kaya to do that, we either divide the whole term by 36 or we can multiply this by 1 over 36. So then this will become x squared over 36 divided by 4 is 9. Diba? So 9 can be written as 3 squared. So then plus, okay, so we have y squared over. So we have 36 divided by 9, that's 4. So 4 can be written as 2 squared. Diba? So then this is equal to 36 divided by 36. So we have 1. Diba? So yung tatandaan natin na pagdating sa semi-major saka sa semi-minor axis, semi-major axis is always greater than the semi-minor axis. Diba? So kaya dito sa dalawang given na to, so yung dalawang nasa ilalim, 'di ba? So makikita natin na mas mataas yung 3 compared sa 2, 'di ba? So therefore, 3 yung i-consider natin as the semi-major axis, 2 yung gagamitin natin as the semi-minor axis. So therefore, A is equal to 3, B is equal to 2, 'di ba? And makikita natin yung 3 is nasa ilalim ng X, yung 2 is nasa ilalim ng Y. Therefore, yung A is nasa ilalim ng X, B is nasa ilalim ng Y, 'di ba? So that is horizontal ellipse, di ba? So ganito yung orientation niya. So na parang nakahiga yung ellipse natin, di ba? Pag nasa ilalim ng Y yung A, so then that's a vertical ellipse, no? So although makikita naman natin siya sa sa figure natin later, no? So makikita natin yung form nito is x squared over a squared plus y squared over b squared is equal to 1, di ba? So again, so this is a horizontal ellipse. So horizontal ellipse yan. Okay, so again, pag walang minus h saka minus k, kasi x squared saka y squared lang yan, diba? So then, so this is centered at the origin. So the center is at 0, 0. Okay? So therefore, so kung i-graph natin siya, okay, so we will find something like this. Wait ko na lang. Dito na lang siguro, no? Okay? So this is the y-axis. No? So then this is the x-axis. Okay? So this is the origin. Okay? So centered at the origin. So start tayo dun. Okay? So we have a center here. Okay? So then, so again, A is 3. And 3 is under x. Diba? So ibig sabihin, so that's along the x-axis. So we have mag-a-add ka ng 3 units horizontally. Diba? So then mag-a-add tayo ng 3 units dun sa kabilang side din. So we have negative 3. So again, from the center. So yun yung ibig sabihin ng A. No? Okay? So again, so yun yung ibig sabihin ng A natin. Diba? So and that's under X. Okay? So yung B naman natin, diba? So is under Y. Okay? So kaya that will be above here. Diba? So pataas. So sa vertical naman. So tapos from the center pababa. So another 2 units. So we have negative 2. Okay? So which means, diba? So ito yung magiging ellipse natin. So we will form this ellipse. Okay? Okay ba? So again, so yung ellipse natin is symmetric with respect to x and y axis, no? Okay? So kaya dapat symmetric yung figure natin. Okay? So yan. So meron na tayo ng ellipse, diba? And sabi dito, this is the volume is generated by revolving about the line x is equal to 3, diba? And gaya ng sabi ko sa inyo kanina, sabi x is equal to 3, so vertical line passing through x is equal to 3. Okay? So again, basta x is equal to a constant. Okay? So again, so this is x is equal to 3. So this will serve as our volume of revolution. Okay? So kaya ma-realize natin, di ba, may imagine naman natin na makukuha natin na figure. So in this case, di ba, is parang donut, di ba? So yung itsura. Okay? Like this one. So parang ganito yung magiging itsura ng figure natin. No? Okay? So again, so itong part na to, so you can imagine ito yung parang hole, di ba? Butas doon sa donut. Okay? Nakuha ba? So yan. So yan yung figure natin, di ba? So pero again, di ba? So what we want to do here is, okay, so to get the volume, di ba? So of this solid, di ba? So and makikita natin since meron yung butas sa gitna, so then, so one way to solve this, di ba, is by using the washer's method, di ba? So then the other one is by using cylindrical shells, no? Pero kagaya nung ginawa natin kahapon sa cylindrical shells, okay? So pwede nyong gawin is, pwede nyo i-consider yung buong to, di ba? Or pwedeng kalahatiin nyo lang. So since dahil naman sa symmetry ng ellipse, di ba? So yung area above the x-axis or yung area above the x-plane, di ba? So it's just the same as the volume above the x-plane, so will be the same as the volume below the x-plane, diba? Or xz-plane to be exact. No? Okay? Naka ba? So pwede nyo gawin yan. So try nyo na lang kung gusto nyo since naituro ko naman sa inyo kahapon yung paggamit natin ng cylindrical shells. So now, so we will try washer method in this case. No? So tapos later on, Pappus theorem. Okay? So again, so para makita nyo yung iba't ibang method natin sa pag-calculate ng volume of revolution. Okay? So again, so dito, so kukunin natin yung cross-section, di ba? So remember, sabi ko sa inyo kahapon, cross-section natin for the disk method so is perpendicular to the axis. Ganun din pagdating sa washer method, di ba? So ibig sabihin, ito yung i-consider natin. Okay, so na cross-section. Horizontal, di ba? So kasi vertical yung ating axis of revolution. Okay? So you can imagine na pag kinuha natin yung cross-section nito, so magkakaroon yan ng butas sa gitna, di ba? So we have this hole. Okay? So nilagyan lang natin ng konting thickness, diba? So then makikita natin na yung thickness natin is along the vertical, diba? Okay, so kaya alam natin that this is dy, diba? So yung dH natin, so dun sa washer method equation is equal to dy, diba? So now as for the radius, diba? So remember, this is 3 units, diba? Tapos nasaan yung original natin na ellipse, diba? Ito yung original na ellipse, diba? Yung naka-center dun sa origin. Okay, nakaba. So therefore, ito yung magde-define sa atin ng x-coordinate saka y-coordinate. Diba? Okay. So okay, so yung magde-define sa atin ng x-coordinate saka y-coordinate. Okay? So now, let's define a point. Diba? So dun sa ellipse natin. So let's say I define this point. So yung ini-intersect ng hole natin. So dun sa ellipse natin. So then we can define this. Diba? So as our x-coordinate. Diba? So this is the x-coordinate. Okay? So and due to symmetry, 'di ba? So of the ellipse, alam natin na pag kinuha natin yung mirror niya, 'di ba? So with respect to the y-axis, remember the y-axis contains the minor axis, 'di ba? So of the ellipse. So meaning yung ellipse natin should be symmetric with respect to the y-axis, 'di ba? So pag mirror natin siya dito, ito yung lalabas na point, 'di ba? So dun sa ellipse natin, makikita natin ito naman yung dulo or yung isang point natin. So dun sa outside circle, diba? So nung disk natin or nung washer natin. Okay? Nakuha ba? So so yung layo nito, diba? So mula sa y-axis should also be equal to x. So again, so due to symmetry, diba? So in terms of coordinates, alam natin this should be positive and this should be negative, no? But again, so in this case, we are talking about the distance, diba? So or the absolute distance or the positive distance, diba? So kaya pwedeng gawin natin parehong positive yung x. So kaya x na lang yung gawin natin dito pareho, no? Originally, dapat yan ay positive x saka negative x. But again, so we want the distance. So therefore, okay, so ito, pag ni-negative natin to, so then yan yung mapupunta dito. Diba? So kaya no need to multiply by -1. Okay? Okay ba? So again, absolute distance yung kailangan natin. We need the positive value. Okay? Kaya parehong x lang yung lalabas dyan. So therefore, what are the radius na kailangan natin? So first, the inner radius. Diba? So let me use... Okay, so ito na lang. Okay, so again, so for the inner radius, diba, so of the hole, so ito yan. Diba? So makikita natin that that is the same as this one. So since this is 3 units, tapos ito ay x units, so alam natin that this should be 3 minus x units. Diba? So then for the outer radius, so again, ito yung inner radius natin. Okay? For the outer radius, so that will be from here, diba? So hanggang dito sa axis of revolution natin. Okay, so since this is x units and this is 3 units, diba? So alam natin that this should be 3 plus x units, diba? So ito naman yung ating outer radius, diba? So then, so kompleto na natin yung mga kailangan natin for the washer method. So recall from yesterday, dv, diba? So for the washer method is given by pi multiplied by outside radius squared minus inside radius squared multiplied by dh. Okay, so then substituting, okay, so yung mga nakuha natin, so this will be pi multiplied by, so this is 3 plus x quantity squared minus 3 minus x quantity squared, so then dh. Ang dh natin ay dy, di ba? Okay, so then let's simplify first. Okay, so we can expand this using binomial theorem. So you have 9, so plus 6x plus x squared. Then minus, so you will get 9 minus 6x plus x squared. No? So then, this is multiplied by dy. Diba? So then 9 minus 9 is 0. So kaya magka-cancel to. X squared minus x squared is 0. Kaya magka-cancel din to. Diba? So 6x minus negative 6x is positive 12x. Diba? So then multiplied by pi, so you will get 12 pi. So then x dy. Diba? So this is our differential area. Okay? So then, diba? So area natin, therefore, so will just be the integral. So pag kinonsider natin lahat ng washer dito, so that will cover mula dito sa pinaka-top ng ellipse natin hanggang sa pinaka-bottom ng ellipse. Therefore, from -2 to +2. So kaya this will be -2 to +2. Pero again, gaya na sabi ko kanina, so due to symmetry, pwedeng ang kunan nyo lang ng volume dito is mula sa kalahati, diba? So papunta sa pinaka-top. So from 0 to 2, tapos i-multiply nyo lang ng 2. Kasi pareho lang yung volume sa taas at sa baba. No? Okay? So pero ito na lang gamitin natin. So i-factor out ko pala muna yung constant. So which is 12 pi. Okay? So ako nung nag-review ako, sinasanay ko yung sarili ko dati na fina-factor out ko kaagad yung constant. No? So para mabilis siyang ma-solve ng calculator. So minsan kasi bumabagal pag masyado maraming laman yung integral. So kaya pag pinapasok ko usually sa calculator, dapat naka-simplify na. No? Okay, so now, ang problem na lang natin is, this is in terms of x, but we are integrating with respect to y. Diba? So kaya dapat ilipat natin yung x in terms of y. Remember, x is the x-coordinate so for the given ellipse. Diba? So therefore, it should satisfy the original equation. So we can either use this one, so or yung sinimplify natin na standard form to solve for x. No? Okay? So again, so pwede nyo gamitin, diba? So yung okay, so again, so pwede nyo gamitin dyan yung positive, no? So square root, pwede nyo rin gamitin yung negative square root. So although pag negative square root, diba? So i-multiply nyo pa ng -1. So kaya babalik ka lang din sa positive. Kasi nga positive distance yung kino-consider natin. Diba? So therefore, so gamitin na lang natin yung positive square root. So ano ba magandang gamitin? So let me use this one. Okay? So pag ito yung ginamit natin, solving for x, diba? So I will leave you with the algebraic manipulation here. So kayang-kaya nyo naman tong i-rearrange, diba? So ang lalabas dyan ay 36, diba? Okay? So again, so this is 36 minus 9y squared, no? So then this is divided by 4. Okay? Nakabasa din square root. Diba? Okay? So therefore, so this will be 12 pi. So then integral from -2 to +2. Okay? So then, so this will be x. Yung x natin dito is square root of, okay, so we have 36 minus 9y squared divided by 4. Okay, so then this will be dy. Diba? Okay? Okay ba? So kaya pwede na natin to actually, dv pala to, not dA. Okay? So dv. So volume. So then, so pwede na natin ma-solve dito yung volume. Diba? So diretso nyo na lang to sa calculator. Diba? So if you want more simplified version, so then, pwede natin ditong ilabas tong square root of 4. Square root of 4 is 2. 12 divided by 2 is 6. So pwede nyo gawing 6 pi ito para wala ka ng over square root of 4 dito. No? Okay? So pwede rin i-factor out nyo yung 9. So dun sa square root. Diba? So dito. Pwede nyo i-factor out yung 9. Square root of 9 is 3. So then you can multiply 3 yung nasa labas. Diba? So, okay, so para mas simplified. So although I think kaya na naman ng calculator tong integration ito. Okay? So from -2 to +2. Okay? So okay, so medyo matagal siya masosolve ng calculator kasi nga merong square root. No? Okay? So this should be 355.3. No? So ito dapat yung lalabas sa solution. So this is letters. Okay? So yan. So pwede nyo rin i-try sa calculator nyo. No? So kung meron kayong calculator dyan. So again, so para ma-check nyo kung tama yung 355.3. No? Okay? So any questions? No? So okay, so another method na pwede natin gawin dito is using Pappos theorem. Okay, okay ba? So gamitin ko na rin lang tong figure na to. Okay? So for Pappos theorem, so ang kailangan nating i-focus doon is yung area, 'di ba? So na i-revolve natin about an axis. So therefore in this case that is the ellipse, 'di ba? Okay. So burahin ko lang 'to, no? So okay, so dito tayo magfo-focus sa ellipse, 'di ba? So yung una natin kailangan malaman, 'di ba? So is the area, 'di ba? So of the ellipse. So itong area na 'to. Okay? Okay ba? So yung tatandaan natin for a given ellipse, 'di ba? Okay? So for a given ellipse, 'di ba? So let's say you are given so some ellipse, 'di ba? Okay? So then yung semi-major axis, 'di ba? So will be from the center papunta sa isang vertex ng ellipse, 'di ba? Pag sinabi nating vertex ng ellipse, so yun yung nasa endpoint ng major axis. Major axis is the longer between the two diameters, 'di ba? The longest diameter so of the ellipse, 'di ba? So ibig sabihin, so ito yung major axis natin. So kaya mula dito, so hanggang dito, so ito yung ating semi-major axis, 'di ba? So yun yung dinedenote natin as A. 'Di ba? So then ito naman yung tinatawag nating co-vertex, itong dalawang to. Ito naman yung shortest diameter ng ellipse. That's what we call the minor axis, 'di ba? Kaya mula center so hanggang co-vertex, so that's the semi-minor axis. So yan yung tinatawag nating B, 'di ba? So and just remember so that the area of the ellipse, 'di ba, is given by pi AB, 'di ba? So direct formula yan, okay? Nakaba? So kaya tandaan nyo lang, 'di ba? So madali lang naman siyang tandaan, 'di ba? So in my case ang tinatandaan ko lang dyan is if A is equal to B, so then tawagin natin as the radius R, diba? So makukuha natin that the area is equal to pi R squared. Okay? Okay ba? So which is area of the circle. So kaya madali lang tandaan kasi pwede mong isipin as pi times R. Yung isa dito ay semi-major axis, yung isa dito ay semi-minor axis. Diba? So kaya palitan mo lang yung isang R ng A, palitan mo lang isang R ng B. Diba? Okay? So again, you can prove that using area, 'di ba, of a parametric curve. Mas madaling i-solve yung area ng ellipse pag kinonsider mo siya sa parametric curve, no? So pero madali lang naman tandaan yung formula. So kaya tandaan niyo na lang, no? So akin ano yung A natin? Ito, 3 units. B natin is 2 units. So therefore, okay? So therefore, so yung area na gagamitin natin in this case is pi AB. So this is pi times 3 times 2. So you will get 6 pi. So again, this will be in square units. No? Okay. So lumabas na pala yung sagot sa calculator ko. So 355.3. So tama yung binigay ko sa inyong sagot. No? Okay. So now, diba? So okay na sa atin yung area. So next is the center. No? Okay. So ang tatandaan, centroid. Diba? So next. Okay. So ang tatandaan natin sa centroid, diba, is one property of a centroid is always located at the axis of symmetry of a given figure. Diba? For example, 'di ba, yung sa parabolic segment natin last time, okay? So yung binigay ko sa inyo, 'di ba? So again is nasa axis of symmetry ng parabola. 'Di ba? So again somewhere dito yung centroid niya, okay? So ganun din sa ibang shapes natin, 'di ba? So basta axis of symmetry, alam natin na nandoon yung centroid ng figure natin, 'di ba? So kaya pag meron kayong alam na 2 or more axis of symmetry for a given figure, madali niyo hanapin yung centroid. Hanapin niyo lang yung pinaka-intersection nila, 'di ba? Okay? So this time, 'di ba? So dito sa ellipse natin, 'di ba? Nagkataon dito na meron tayong dalawang axis of symmetry, 'di ba? The minor axis and the major axis intersecting at the center. So kaya alam natin yung center natin is the centroid of the ellipse. So balik tayo dun sa figure. Okay? Okay? So again, itong center na to, ito yung centroid ng ellipse natin. So kaya para makuha natin yung C-bar, so dun sa Pappos theorem natin, kailangan natin hanapin yung distance nito mula sa axis of revolution. But we know that that is equal to 3 units. Diba? So therefore, alam natin na, okay? So yung C-bar natin, diba, is equal to 3 units. Okay? So therefore, by Pappos theorem, okay? So we will get that the volume, diba, is equal to area multiplied by 2 pi C-bar. Okay, so we have 6 pi square units, no? So multiplied by, so we have 2 pi multiplied by, so 3 units. Okay, so then this is equivalent to, okay, so we have 6 pi times 2 pi, so times 3. So we have 355.3 cubic units. Diba? Okay, so kaya again, Pappus theorem is the fastest way usually to solve for solids of revolution. Pero again, so dalawa yung requirement nyo dyan. Diba? So dapat alam nyo yung area saka yung location ng centroid. Diba? So kaya again, so pag may time kayo, so aralin nyo yung mga conic sections natin. Diba? So yun kasi mga madalas na lumalabas. Circle, parabola, ellipse. Diba? Saka mga parts nila. Diba? So sa semi-parabola, semi-ellipse, semicircle, quarter ellipse, saka quarter circle. So syempre may mga lumalabas din na ibang figure. Diba? So minsan may lumalabas sa sinusoid. Okay? So minsan may lumalabas na exponential. Diba? So putol nga lang. Diba? So kasi infinite yung, hindi naman siya loop. Diba? Okay? So kaya minsan pa iba-iba din yung lumalabas na figure. Pero most of the time, conic section yung ma-encounter nyo sa board exam. Diba? Kaya malaking tulong na rin pag memoryado nyo yung mga direct formula. Diba? So yun, syempre, hindi lang naman sa volume of revolution yung magagamit yan. Kasi minsan, tinatanong din mismo yung area. Minsan, tinatanong mismo yung centroid. Kaya kung memoryado nyo yung direct formula, no need for integration. Diba? So yun yung pinaka-advantage nun. Okay, so let's proceed to the next topic. Diba? So we have a centroid of an area. Okay. So for the centroid of an area, diba? So ang tatandaan nyo lang dito is, okay, so let be the centroid of an area. So be given by G, diba? So such that this will be X bar, Y bar, diba? So then, okay, so yung X bar multiplied by the area, diba? So of the object, okay, so is given by the summation, diba? So this will be the centroid, so X of I, diba? So of parang area, diba? So or smaller area na part ng hinahanapan natin ng area, so multiplied ng area niya, diba? So overall values of I. Okay? Nakuha ba? So or if we make the area infinitesimal, so or very small, so then we can write this as the integral, diba? So ng X. Okay, so tawagin natin to as X sub C, diba? So ito yung centroid ng infinitesimal area natin multiplied by the differential area, diba? So this is overall or over the whole area natin. Okay, nakuha ba? So for example, diba? So again, so let's say you are given so some figure like this one, diba? So then the idea is we can break this down so into smaller areas, diba? For example, A1, A2, A3, A4. So tapos pag alam natin yung centroids, 'di ba? So nung mga individual areas na nakuha natin, pwede natin gamitin 'to, 'di ba? Or another option, 'di ba? So is pag hindi natin wala tayong makuha na common figure, so kung saan makukuha natin yung mga centroids, 'di ba? So then we can make let's say small strips, 'di ba? So let's say we have vertical strip, 'di ba? So alam naman natin na pag vertical strip, 'di ba? Sobrang nipis niyan. So kaya yung length lang yung pagbabasehan natin sa centroid. Nandun siya sa pinakagitna. Diba? Okay? Nakuha ba? So, or we can even use, diba? So, yung, okay, so double integration. So, although pagdating sa centroid, I don't recommend the double integration kasi mas magiging complicated lang equation niya. Diba? So, ganito kasi yung double integration. dy dx, diba? Yung centroid niya is yung position niya mismo. Diba? So, pero again, so hindi natin dadaanan yung double integration. Diba? So, we will use either vertical strip or horizontal strip lang. So horizontal strip ganun din, yung centroid niya is nasa pinakagitna, 'di ba? Kailangan lang natin kunin yung coordinate niya, 'di ba? So yung x and c. Okay? So similarly, so for y, so y bar times the area is equal to the summation, 'di ba? So nung smaller areas, 'di ba? So this is all overall values of I, okay? So ng y sub I, so again ito yung centroid niya, so times the area. Okay, so for smaller areas, diba? So pwede rin natin gamitin yung integral, diba? So if we use infinitesimal areas. Okay, okay ba? So any questions? Diba? So para dito. Okay, so again, so yan yung tinatawag natin na centroid. So syempre pag may pag three-dimensional yung pinag-uusapan natin, so dadagdagan nyo lang ito ng z component. Diba? Okay, so although I think wala pa ako nakikitang problem sa board exam na centroid of a volume. As in yung volume na hindi volume of revolution, di ba? Yung solid of revolution lumalabas yan sa board. Pero yung solid of revolution kasi madali lang kunin ng centroid kasi alam natin na nasa axis of revolution. Kaya isang dimension lang yung sinasolve natin. Okay? So wala pa ako nakita problem sa board na tatlong dimensions yung isa-solve nyo sa centroid. Okay? So 2 dimensions lang or 3-dimensional na solid of revolution. Okay? Okay? So any questions para dito sa centroid of an area? Okay? So let's try an example. Now, so again, so ito din nakadepende sa problem na kung ano yung gagawin niyo. Pag yung figure natin, 'di ba? So is hindi natin mahahati into common figures, 'di ba? So then it's better to use integration, 'di ba? So pero kung kaya naman natin siyang hatiin sa common figures, so we can use yung division, 'di ba? Okay, so i-divide natin siya into common shapes, okay? For example, ang given sa atin is ganito, 'di ba? So ito may lumabas ang ganito dati sa words. No? Okay? Pentagon, 'di ba? Okay? Nakuha. So yung pentagon is ni-revolve about this axis. Parang ganyan yung problem, diba? So kaya pag ganitong problem kasi mas maganda gamitan nyo to ng Pappos theorem, no? Mahaba kasi ito pag ginamitan nyo to ng washer method, okay? So or pag ginamitan nyo to ng cylindrical shells. Kasi marami ka ditong lines na involved, diba? So kaya kakailanganin mo ng different division, diba? So ito yung unahin mo. Kasi ito yung lower boundary, upper boundary. So then ito yung pangalawa. So we have lower boundary, upper boundary. So then ito yung pangatlo. Lower boundary, upper boundary. Diba? So kaya apat, parang hatiin mo pa ito sa apat na division. No? So apat na figure bago mo magamitan ng cylindrical shell or this method. Diba? Or washer method. No? Okay? It's better to use Pappos theorem. So kaya mas maganda i-solve nyo na lang yung centroid nito. Diba? And yung pinakamagandang gawin dito is, diba? So hatiin mo siya sa triangle. So then we have triangle, triangle, saka rectangle. Diba? Okay? So this is the easiest way. Diba? So kaya pwede natin gamitan ng ganito. Okay? Okay ba? So any questions para dito? Okay? So yan. So pero pag yung figure natin again is yung mga curve. Diba? So for example, ganitong curve. Okay? So then, hindi natin siya mahahati sa alam natin yung location ng centroid sa area. Diba? Okay? Or actually pwede, diba? So pero depende pa dun sa curve natin. Okay? So pero pag ganito, mas madali na itong gamitan ng horizontal strips or vertical strips. No? Okay? So try natin. So example. Okay? Find the coordinates of the centroid of a plane area so bounded by the parabola and the x-axis. No? Okay, so first, okay, so let's start with the parabola. Y is equal to 4 minus x squared. Okay, standard form. So again, dapat naka-isolate yung x squared. So then this will be equal to negative y minus 4. No? Okay. So this is negative y minus 4. Diba? Okay, so kaya makikita natin na yung format, diba? So nung equation natin is of the form x squared or x minus h squared. So this is equal to, so we have 4a, so times y minus k. No? Okay? So kasi may nakasubtract kay 4. Kaya meron tayong minus, may nakasubtract na 4. Kaya meron tayong minus h saka minus k dito. No? So again, so this is centered. So actually negative to. So kasi negative yan. So this is again, ang vertex nito is nasa hk. Diba? So then yung parabola natin is opening downward. No? So kasi x yung naka-square, so tapos negative yung y. Diba? Okay? So therefore, so dito, so yung vertex natin, so will be located at 0, 4. Okay? So then, so we get the points of intersection ng boundaries natin. Ang boundary natin is ito, saka yung x-axis. So ang x-axis is y is equal to 0. So therefore, so let's solve. At y is 0. So what happens here? So we have 0 is equal to 4 minus x squared. So x squared is equal to 4. So x is equal to plus or minus 2. So therefore, so yung dalawang points of intersection natin is 2, 0, saka negative 2, 0. Okay? Nakuha ba? So kaya pag ginraph natin yan, so ganito lang yung shape niya. Okay? So x-axis, y-axis, origin. Okay? So let's say this is 4 units. So this is 2 units. So this is 2 units as well. So negative. Okay, so then we have a point at 0, 4. That's the vertex. Negative 2, 0, saka 2, 0. Diba? So you will get this parabola here. Okay? Okay ba? So again, so for the area, kung gusto nyo i-integrate, so kayo na yung bahala. Pero since alam naman natin yung direct formula, so gagamitin ko na diretso yung direct formula dito. Diba? So again, so this is 4 units. Okay? So then, this is also 4 units. Okay? So then the area of the parabola is simply 2/3. So times base times height. So parehong 4 units lang yan. So kaya times 4 times 4. So this is 32/3. So actually basta mga parabolic segment na tanong sa board, no? Ang madalas niyo makikita mga sagot diyan ay 16/3, 32/3, 64/3. So something over 3. Okay? So yan yung lumalabas na area natin. So we have 32/3 units. Okay? Okay ba? So any questions so far? Okay? So now that we have the area, diba? So then to solve the centroid, okay? So again, so one way, so is by using, okay, so a vertical or horizontal strip. So pero gamitin na lang natin yung mas madaling gamitin dito. So obviously that is vertical strips, no? Bakit vertical strip? Kasi pag horizontal strip yung ginamit natin dito, so ang boundary natin so will be a parabola and another parabola, diba? So ibig sabihin or half parabola and half parabola. So magkakaroon tayo ng square root. Okay? So kahit hatiin natin yan sa dalawa, for example, ito lang yung kinonsider natin, diba? So again, that's still a half parabola. So and the y-axis. So that will contain square root, diba? And kagaya nung sinusolve natin sa calculator kanina, diba? Pag may square root dun sa integral natin, usually, mabagal siyang isolve ni calculator, diba? So that's why, okay? So ang gagawin natin sa problem na to is vertical strips, no? So it will be easier, diba? Okay? So pero pagdating naman sa board, kahit anong gamitin nyo, okay lang. Okay? So again, so we will use this. No? Yung thickness niya is along the x-axis, kaya alam natin na dx lang yan. So tapos, diba? So yung height niya, so will be the distance of a point. So dun sa parabola natin from the x-axis, that's the y-coordinate. Diba? So therefore, so we can say that the differential area dA is simply equal to y dx. So ito pwede nyo gamitin to solve the area as well. So pero since alam na natin yung direct formula, mas madali siyang gamitin. No? So saan natin makukuha yung y from the given parabola? So kaya we have dA is equal to 4 minus x squared dx. Okay? Naka ba? So meron na tayong differential area. Okay? So ano yung next step natin? So yung centroid, diba? So yung position ng centroid, so nung differential area natin. Okay? So nasaan yung centroid niya? So gaya na sabi ko kanina, nasa pinakagitna lang. Okay? Kung nasa gitna yan, 'di ba? So ibig sabihin, so dito sa y coordinate, okay? So this is simply y over 2, 'di ba? Kalahati lang siya ni y. Okay? In terms of the x coordinate naman, 'di ba? Makikita natin na kapareho lang siya ng distance ng point natin so from the y axis. So that is the x coordinate, 'di ba? So therefore, in this specific problem, okay? So yung x sub c natin, so for the differential area is equal to x. Yung y sub c naman natin is equal to y over 2. Okay? So which means, diba? So again, so in solving for the centroid, start tayo sa x bar. Okay? So x bar times the area is equal to the integral over the area ng x c dA. Okay? So this will be x bar, so times 32/3. Okay, so then this is equal to, so we have integral. Yung x sub c natin is x. Okay, so yung differential area natin is 4 minus x squared dx. So then this will be evaluated, diba? So sa lahat ng sakop niyang rectangle, so that will be from -2 hanggang +2. Diba? So -2 hanggang +2. Okay, pag sinolve nyo ito, lalabas dito x bar ay 0. No? So one thing is kasi ito, this is an odd function. And pag add function, pag yung limits of integration natin ay additive inverse, the result is always 0. Diba? So you can check your calculator. No? So pag tinry nyo isolve yung integral nyo. Okay? Ang lalabas yun ay 0. Okay? So which is just another proof, diba? So or another example, diba? So nung sinabi ko sa inyo kanina that the centroid is always located on the axis of symmetry. So dito ang axis of symmetry natin is the y-axis. Again, the y-axis is treated as x is 0. Diba? So kaya alam natin ito yung isang centroid or isang coordinate ng centroid natin. Diba? Okay, so about y bar? Okay, so y bar A is equal to integral so ng y sub c dA, diba? So kaya y bar, so times 32/3. So this will be equal to integral, diba? So ng y sub c natin is y/2. Okay? So then yung dA natin, so is 4 minus x squared. Okay? So dx, diba? So pero yung y, so alam natin na 4 minus x squared lang. So then what we can do here is just 32/3. So we can factor out the 1/2 here. So 1/2. Tapos yung y natin, pareho lang nito. Diba? 4 minus x squared. So ibig sabihin, we can write that as 4 minus x squared dx. So again, this is over the area. So yung dx natin, so range from -2 to +2. So this is -2 to +2. So let's solve for y bar. Solve nyo lang yung integral, tapos i-multiply natin ng 3/32. Diba? Okay? So we have integral, so ng 4 minus x squared. So then this is from -2 to +2. Okay? So then divided by 2. Okay? So times 3 divided by 32. No? Sorry, nawala yung square pala. So again, so dapat may square to. Diba? Okay? So kasi yung y na to is 4 minus x squared. Diba? Okay, so kaya times another 4 minus x squared. So kaya magiging siyang 4 minus x squared quantity squared. No? So 4 minus x squared squared. So that is from -2 to +2. Okay, so then divided by 2. So then times 3 divided by 32. So you will get 1.6. No? So therefore, so the centroid is located at x bar, y bar. So this is given by, okay, so we have 0, 1.6. No? Okay, so we have letter B. Diba? So ibig sabihin nandito yung centroid natin. Okay, so somewhere here. Okay, so this is our centroid. Okay? So syempre another way is by using direct formula. Diba? Binigay ko na sa inyo last time or kahapon yung direct formula natin for the centroid of a parabolic segment. Diba? So again, that's 2/5 ng height mula sa base. Diba? So doon sa figure natin, okay? So yung base natin so is yung x-axis. Diba? So kaya basically, so alam natin ito ay 2/5 ng height. Diba? So which is yung y bar na mismo. Kasi again, so nasa x-axis siya. So alam natin nasa y-axis yung centroid natin. So kasi siya ay nasa axis of symmetry. Kaya alam kagad natin na x bar ay 0. Diba? So therefore, okay, so pag gagamitin natin yung direct formula na yon, so we have x bar is 0. Diba? So again, this is axis of symmetry. Okay? So yung pangalawa, diba? So y bar is 2/5 ng height. Diba? And again, from the figure, ang height natin is 4 units. So kayo lumalabas na y bar is equal to 1.6. So makikita natin pareho lang yung makukuha natin sa pag. Diba? Okay, so using the direct formula. So kaya it's better kung memoryado nyo yung direct formula for the centroid. So kasi hindi lang naman sa centroid yung magagamit yan. So even sa solid of revolution. Okay, okay ba? Magagamit nyo rin yan sa ibang mga tanong, di ba? Mga center of mass, center of pressure, di ba? So yung mga fluid force, okay, so etc. etc. Okay? So any questions so far? Okay. Okay. So let's proceed to the center of mass. No? Okay. So yung center of mass naman, di ba? So as the name implies, okay? Para lang siyang centroid, okay? The only difference is instead of dealing with area, we are considering the mass, di ba? So kaya pagdating sa center of mass, nakadepende ito sa problem. Okay, naka ba? So meron tayong 3 types na kino-consider pagdating sa center of mass, di ba? So we have linear, di ba? So then yung isa is lamina. Okay, so tapos yung isa naman ay solid, no? Okay, so syempre pag linear, so this is one-dimensional, di ba? Lamina is two-dimensional, so then solid is three-dimensional. Okay? Naka ba? So yun lang itatandaan nyo dun. Okay? So pag linear, 'di ba? So syempre so we have yung tinatawag natin as the linear density, usually denoted by delta. So although wag kayo malilito sa mga ano nito, sa mga symbols na ginagamit natin kasi minsan nagbabalik-baliktad yan depende sa reference. So sa board exam, minsan yung delta nagiging lamina, no? Okay? So yung ginagamit sa lamina na raw, minsan nagiging solid. Okay? Tama ba? So kaya ingat lang kayo, no? Kasi nagbabago-bago yan depende sa problem. Okay? Tama ba? So again, so this is the linear density. So yung lamina ay sigma, usually yung ginagamit. So ito yung tinatawag nating surface density, di ba? So ito yung sa area. Okay? So then, so yung solid naman ang ginagamit natin is rho. Diba? So which is the mass density. Okay? So alam naman natin yung ibig sabihin ng mass density, diba? Okay? So that is mass per unit volume. Okay? So kaya to solve for the total mass, diba? Or yung differential mass natin dito, dm. So this is simply equal to delta, so multiplied by ds. So yung ds natin is yung arc length. Okay? Nakuha ba? So this is the length. Okay? So kaya yan yung kino-consider natin. So kaya if we want to solve for the center of mass, no? So x of m. Okay? So this is simply equal to, so i-multiply lang natin to ng mass. Okay? So then this is equal to, diba? So we have integral, diba? So this is x of c, diba? Or gawin natin tong bar, no? So then this is x of m. So this is the center of mass of the whole line, diba? So pero dito, so this is just the center of mass of the differential area, diba? The differential mass. So this will be dm. Okay, nakuha ba? So over the whole mass. Kaya again, so para lang siyang centroid, papalitan nyo lang yung area ng mass. Okay, nakuha ba? So for the y component, so then magiging ganito. So then y sub m, so then we have dm. Okay, nakuha ba? So pwede nyo rin gawin yung composite na ginawa natin kanina. Yung summation, so ng x sub i, m sub i. So we have x sub I, m sub I, so overall values of I. Okay? So although bihira ako makakita ng ganitong problem pagdating sa center of mass. Sa centroid lang talaga nagagamit ito usually. No? Okay? So and also note na yung centroid natin hindi lang sa area yan. Diba? So meron din tayong centroid of a line, saka meron din tayong centroid of a volume. Diba? So papalitan nyo lang yung area doon. So pag center of a line, centroid of a line, ang kino-consider natin yung arc length. So yung DA, papalitan nyo ng DS. Yung A, papalitan nyo ng S. Diba? So pag volume naman, papalitan nyo lang yung area ng volume. Okay? Sa two-dimensional naman, so then, ang i-consider natin dito area. Diba? So kaya sigma DA. Diba? So tapos ganito na uli yung magiging equation. Okay? So after nito, pag nakuha nyo na to, so then, so yun yung ipapasok nyo ngayon dito. Okay? Saka dito. Okay? Nakuha ba? So pagdating sa volume, diba? So then yung dm naman natin, so will be rho dv. Okay? Okay ba? So ito naman yung ipapasok natin dun sa dm. Okay? Okay ba? So kaya yan lang yung sa center of mass natin. So yan lang yung difference. Okay? So yan. So pag sinabi nating lamina, ano to? Usually this is a plate. Diba? So kaya area lang yung kino-consider natin. So isa siyang, isipin siya parang sobrang nipis na plate. Diba? So baga meron tayong certain area, tapos yung thickness niya, so sobrang nipis. Okay? Ba? So na hindi na natin kino-consider or hindi na importante yung pagkaka-distribute ng mass natin, so dun sa thickness niya. So mas importante yung sa area. Diba? Okay? So then, so let's try an example. Okay.